Hey Math 1 students, Math 1, Module 1, Topic 1 corrections here, and this is Power Standard 7.1. Students can use appropriate vocab and notation to describe a given representation. Before we begin, you should notice that numbers 1, 2, and actually even number 3, they all have different questions, but the functions in each of those questions are actually all the same. So a of x equals negative 2/3 times x is the same for number 1, for number 2, and even for number 3. So just something to note, because I'm only going to do a few of these functions with you guys, and then you should try the remaining ones. So question number 1, classify each function as increasing, decreasing, or constant. Well, remember, increasing means going upwards from left to right. Decreasing means going downwards from left to right. And constant means this flat, horizontal, linear function. All right, so let's see what's going on with these functions. So the first one, a of x equals negative 2/3 times x. It's a little difficult to tell just by looking at these equations whether or not it's going to be increasing, decreasing, or constant. So one thing we can do with these functions is use a graphing tool to type these equations in and see the visual representation of what these functions are, and then we can tell if it's increasing, decreasing, or constant. So I'm going to pull up Desmos, and I'm actually going to split screen that. I already have Desmos pulled up. That was not a split screen. That's a split screen. All right. And I'm going to type in each of these functions, and we're going to figure out what's going on with it. So the first one, a of x equals negative 2/3 x. I can type in up here exactly as you see it on the left side. So I'm going to click on this ABC and then type the letter A. Then go back to the rest of the functions and click on the parentheses. There's an x right above the parentheses, so a of x equals negative 2/3 x. For the negative, you can just use the minus sign. 2/3, you can type in 2 divided by 3, and the division sign will give you this fraction. And then to put the x in there, you can't put it below like this. This is not good. So to put it above, you want it next to the 2/3. Delete that one. You have to move this cursor to the right side. So click on the right arrow here, and then press X. So then now we see it's negative 2/3 times X. And then the picture of that graph is over here. If you want to minimize this over here, you can click the double arrow, and we have a bigger picture. And I can see that this guy going from left to right is actually decreasing, right? So the left side to the right side across the domain is decreasing. Decreasing. All right, so that's a of x. Let's do another one, and let's call this b of x. And b of x was a little easier. This is just b of x equals 4. So b of x equals 4. This graph is in green. Desmos tells you which one is which. So again, if I minimize this, it's the green function. And I see that it's just flat, right? It's not increasing or decreasing. It's just constant. So this function is constant. All right, next one, we have c of x equals 2 to the power of x minus 2. So how do I get an exponent? Well, by looking at these, you're going to click on the top right one over here that has a to the power of b, and it creates this cursor as an exponent. So now I can type in x minus, uh-oh, that's not good. Let's click the left there. You may have to click parentheses here. So we have 2 to the power of x minus 2. You're going to have to put that in parentheses. Apparently Desmos doesn't read it if you just put minus 2. So put x in parentheses minus 2, and then that's the same thing as this over here. So looking at this, this is kind of confusing. I got like 3 different functions here. So one thing you can do with Desmos is you can turn off the graphs of these other guys just by clicking on the color over here. So I don't want to see number 1 and 2 anymore. So I'm going to turn them off. And now I just see this last one that we just graphed. We're going from left to right. It's increasing. All right, I'm going to turn that one off. And then let's go ahead and do letter D. D of x. So D parentheses x, close parentheses, equals negative 3x squared, right? So to the power of 2. You can actually just click on the one right next to the one that we just used. So this one that says a squared, because that'll create just a exponent of 2. So it says negative 3x squared. All right, and over here we have the picture that Desmos just drew for us. I'm going to, again, minimize this so I can take a better look. And we got this U shape, right? So we see that going from the left side to the right side, this function starts off going up, 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 up. So it's increasing, increasing, increasing. Hits a maximum point, and then it starts going down, 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 down. So it's decreasing after that. So this is actually a combination. It increases, then it decreases. So for letter D on this side, I'm going to say increases, then decreases. All right, so back to Desmos. I'm going to do letter E with you. So I'm going to get rid of this function again, not closing it out completely. I just don't want to see it on the graph. And I'm going to do E of x now. All right, so the next function is this one on the left side that says E of x equals 4 times the absolute value of x plus 2. And I just figured something out in Desmos. If I actually type in E of x as it's written, it's not going to read it. So you can see here, when I type in E, it actually gives me a number, and that's the reason for that is that E is actually a numbered math. I won't get too much into that at all, really. So if you type in E of x, you're not going to get a function that actually shows up. And I'm doing that here so you can see E of x plus 2. And yeah, so nothing shows up over here. And the reason is because it's reading E as a number, not a variable. So that's fine. We just won't use E of x. The nice thing about functions is that we don't always have to have this function notation. We could actually just use y equals. So let's just use y equals 4 times the absolute value, which was down here, of x plus 2. So we have x plus 2. And there is our function. We have this V shape. which starts off from left to right, decreasing, then increasing. So I can say this is decreasing and increasing. So now that we finished this, I'm going to zoom out a little bit so that we can see the next question, number 2. Classify each function as a linear function, linear absolute value function, quadratic, or an exponential. I'm going to draw the shapes of each of these right above the word. So like linear function, these are the straight lines. A linear absolute value function, these are your V shapes. A quadratic, these are the U shapes that are curved. Or an exponential function, these are like your J shapes or your L shapes. All right, and the good thing is that we actually have the first 5 functions already saved on Desmos. So I'm going to go back to Desmos and look at letter A. So remember, I can just turn off graph number 5 and turn graph number 1, or letter A, back on. And I see that for letter A, negative 2/3 x, we have this line that's decreasing. It's just a straight line, right? And we know that those are the linear functions. Straight lines are linear functions. Okay, turning that one off, let's look at number 2 now, b of x, and we have this straight horizontal constant line. Since it's also just a straight line, this is also just a linear function. All right, letter C, 2 to the power of x minus 2. Right here, I will turn that one on, and I get this L shape or J shape, and that would be an exponential function. And letter D, let's turn that one on. That's this U shape, and that would be a quadratic. Letter E is the absolute value, so the linear absolute value. So like I said, this unit is a lot of just vocab, getting to know your vocab. And then number 3, determine whether each function has an absolute maximum or an absolute minimum. If the graph has neither an absolute maximum nor an absolute minimum, write none. So absolute maximum, I'll draw that picture right above the word maximum over here. These are your high points. And the only functions that we're talking about in this chapter that have absolute maximums are either your quadratic functions that are like this, or your linear absolute value functions that are like this. And the same thing with minimum. The only thing is with minimums, they're going to be flipped. So these are the only 2 functions that have absolute maximums or minimums. The rest of the functions, our linear functions and our exponential functions, they don't have any. So I'm actually going to look at our answers from number 2 and figure out which ones I can put none for. For example, letter A is a linear function. That should have none. Let's actually look at the function over here in Desmos. So if I go back to letter A, turn that one on, we see it's just a line going down. There's no minimum there because it just keeps going down, down, down forever. So I'm going to write none over here in Canvas. Letter B, we have a constant function, constant linear function. And again, these do not have any absolute maximums or minimums. Letter C, this exponential shape, this J shape, this also does not have a maximum or a minimum. Only the U's and the V shapes. All right, d of x, negative 3x squared. Okay, we can see that we have this U shape, right? And this U shape starts off increasing, then starts decreasing, and it reaches a maximum point right here at the point 0, 0, the origin. So this actually has an absolute maximum right at the origin. So for letter D, we have an absolute maximum. Back in Desmos, I'm going to click on graph number 5, and here we have a V shape, and it starts off decreasing, hits a point at the bottom, then bounces back upwards. That bottom point is an absolute minimum. So E has an absolute minimum. All right, I'm going to close out of Desmos. That's pretty much all I need that for. For the rest of number 1, 2, and 3, I didn't do functions f and g. You guys should try those out, see what you get. Number 4, and there's 2 questions for number 4. These are really, do you understand your function families? So like number 4 says, identify the function family of a graph that is a straight line. I'm not going to tell you what the answer is for this one, but it's going to be either linear, exponential, quadratic, or linear absolute value. Which one is just a straight line? And then the second one, identify the function family of a graph that is curved and has an absolute maximum or minimum. So it's going to be one of these. Is it a quadratic or a linear absolute value?